Okay. Well, hello, Lou Kontnick, and I'm sorry for the dramatic entrance. But it's worth the drama, right? It's the lagoon. It's worth the drama. And I want to start by saying thank you to Laura and to the MRC for letting us make you aware. Here locally, I'm going to give you cards, but on the video about the Lagoon Straight Talk, where on December 10th, at the O'Galley Civic Center, we're going to have leading experts, Virginia Barker, Keith Winston, Olivia Escondel, going ahead and telling us in a very brief way what is the latest with the lagoon. And this today will be a good basis for that, because what then after those brief presentations, we'll have an hour and a half of Q&A. You can ask your questions and get straight talk from the experts. So all you've got to do is go to helpthelagoon.org. What is that? Helpthelagoon.org and register and show up and join us. So hope to see you next Tuesday, 5:30 to 8 at the O'Galley Civic Center. Thank you very much, and thank you.
Thank you.
Oh,
You guys
sorry.
too. Get ready. Okay, so today you are going to hear from two speakers who are also on staff here at MRC. First, Dr. Laura Wilson, our Executive Director. Inspired by the natural world, Laura pursues work that brings together her love of learning, teaching, and exploring. Her background is in geology and paleontology, specifically studying ancient marine ecosystems that evolved in a greenhouse climate and comparing them to modern systems. After 12 years in academia, Laura realized she wanted to make a bigger impact on Earth's future. She started as the Executive Director of MRC in June of 2024. Also presenting today is Mara Scadden. Mara is a biological oceanographer, passionate about conserving and restoring habitats. Her background is in biology and conservation, focused on benthic and fauna, which are small little animals that live at the bottom of estuaries and oceans. Mara is working on her PhD in oceanography at Florida Tech, woohoo!
All right.
And she's researching using those benthic and fauna as bioindicators. She's also the Director of Science for MRC, leading the restoration team. And with that, I will turn it over to Laura and Mara.
So thank you all for being here, and thank you, where am I looking, everyone for being online. We're thrilled about the response and the amount of people who want to give up some time on a Tuesday to hear what we have to say, but also hopefully engage in conversation. So I'm the Executive Director here. I'm Dr. Laura Wilson. I've been here for 5.5 months or so. And this has been a huge learning process for me, which has been enjoyable pretty much every day that I'm here. So today, while you're all here, is we want to take some time to break down the report that came out last month, really focusing on things like the data that went into it and the methods, as well as what that means for how we evaluated the lagoon health across the 5 different basins that we analyzed. This was the first year that we produced this report, previously known as the report card in-house. We had usually past years contracted a lot of the science out. We spent most of our time, or Mara spent most of her time, coming up with the methods. And really the idea is to set a baseline that then can be repeated and expanded in future years, now that we've set the methods, identified where the data came from. So we're always happy to hear from the community of ways that we can, suggestions and constructive criticisms for improving upon or expanding the analysis and the methods going forward. When Maura and I first sat down and thought about how to approach the report this year in-house, we really focused on 2 different areas, one being the science and the process of science and analyzing data, and the other being the science communication. So how to communicate the science of the lagoon with a general audience, people who don't have advanced degrees but are voting and boating and things like that. And we took feedback from previous years' reports that we had gotten as an organization and that I had heard in my first couple of months here. And then we also took a lot of the conversations that we got out of the 21st Indian River Lagoon Action Assembly that we hosted with FIT back in August. And that was very much about the ideas of communication and collaboration. So some of the focus that we brought into the report card was clear identification of the data process, of the data collection process, so where the data came from, and then clear methods of how we analyzed those data to reach our conclusions. And those are the fundamentals of the scientific method and the scientific process, and were feedback that we heard needed improving from collaborators within the community. We also wanted to make sure that we were targeting a general audience, so writing it and addressing it to a level that, you know, the average citizen can understand, and that was a big emphasis in how we wrote it. And also the impetus for making it into a digital dashboard versus a 2-page physical print that we'd done in previous years. We could provide more information, more maps, and break it down with explanations a bit more. We also wanted to focus on the collaboration amongst different organizations working on the lagoon, as well as progress being made, and not just be doom and gloom, but actually highlight where things are getting better. So we can say, yes, things need improving, but some things have improved over the year. I do want to emphasize one thing that we tried to emphasize in our text online is that this is a snapshot of data from August 1, 2023 to August 1, 2024. Because we spent so much time kind of inventing our methods for the first time putting this together, we didn't have the capacity to go back multiple years for analyses. We will have room to grow and provide that going forward. So some things like seagrass is a direct seagrass coverage is a direct comparison of 2023 to 2024. So we can say that coverage is better, coverage or worse. Other things like water quality, which Mara will spend a lot of time going into, are more absolutes. They're data that were collected from different monitoring stations and compared to EPA standards. So kind of two different types of data that were reported, again, as a snapshot. At this point, I am going to turn it over to Mara, who's our Director of Science, and did the bulk of the hard work putting together or pulling together the data, reaching out to collaborators to ask them to share their data, and then working with other researchers in the field to come up with the methods and the equations for analysis. So she's going to spend some time to take everyone through where the data came from, how it was analyzed, and then what it says. We will hopefully have lots of time at the end for conversation and questions, and we'll be happy to address everything we need to.
Thank you, Laura. Hey, guys. Like Laura said, I'm Mara Scadden. I'm the Director of Science here at MRC. And like Honor mentioned earlier, I'm also a student at FIT. I'm a doctorate student. I'm in my 3rd year, so just send me some prayers. I can use it.
I'll send you a degree.
Oh, I like him. He gets an extra cookie. Okay, so the goal of me talking today is to kind of explain what we did this year, because it is different than what we've done in the past. And the goal my main goal this year is to get it as clear as possible about where that data came from, what it means, and what it means for the future of the lagoon. So this is kind of, I'm sorry, I'm a flowchart person. So this is kind of our assessment structure. So we have the overall health grades, which is what you landed on when you went on the dashboard. So you said it was all yellow and a little bit of orange, right? So that was okay and poor. And that's what these are what went into those overall grades. So water quality, harmful algal blooms, sediment health, seagrass coverage, and wastewater spills. And then you can see there's a further breakdown into those, and we'll talk about that in a little bit. So just let's go back a little bit and remember what a mean and a median is. So a mean is the average number found by adding all the numbers in a data set together and then dividing by the number of values in the set. We're going to talk about means a lot today. Same with medians. So the median is the middle value in a set of numbers when those set of numbers is arranged from smallest to largest. And I'll explain why that's relevant in a little bit here. All right, so our first subcategory for that overall health grade was harmful algal blooms, or HABs, as we like to call them. And so this data came from WIN, or Watershed Information Network. And I'll actually show you that website in a little bit. And so basically what we looked for was concentrations of chlorophyll A. So chlorophyll A is the main green pigment in plants and algae that is responsible for photosynthesis. And so when we look at chlorophyll A concentration, that tells us how much photosynthesis is occurring in an area. And so for harmful algal blooms, we do not want concentrations greater than 20 micrograms per liter, which is, it's a little bit scientific, but 20 micrograms per liter is way too much chlorophyll in the water. It means we probably have some harmful algae, and things are not going well. And so for the harmful algal blooms category, we looked through all of the data on water quality from Watershed Information Network from August 1st of 2023 to August 1st of 2024, and picked out where there were chlorophyll A concentrations over that 20 micrograms per liter for over 12 hours. So, and that is, we'll go into the basins, but that is what went into each of those basins harmful algal bloom assessment. Okay, seagrass coverage is a little bit different than the rest of our categories. And this is where I would love to hear some feedback from you guys. Maybe you know where some data is that I don't, but seagrass coverage was a direct comparison from 2023 coverage to 2024. And so what I originally had wanted to do with this was take the FWC seagrass habitat map, which shows you the optimal areas for seagrass growing in the lagoon, and compare that to where seagrass was growing in the lagoon. Unfortunately, I wasn't able to get that data in time for the report. I have it now, but we'll share that with you next year. But for these scores, it's a little bit different. So for our better scores, which were the Mosquito Lagoon and North Indian River Lagoon, that was a significant increase in coverage compared from 2023 coverage to 2024. And so the Mosquito Lagoon actually went from 3,800 hectares of coverage up to 6,000 hectares of coverage in the last year. And so we think that's really good. And so we put that in our better score. And then for Banana River, we had the same coverage. Even though the coverage of seagrass in Banana River is poor, there's not very much seagrass there, it was consistent from 2023 to 2024. And that's why it earned an okay. And then our core, which would be like our South IRL basin, had a slight decrease in coverage. So for example, the South Indian River Lagoon in 2023 had 4,000 hectares for seagrass, but in 2024, it had about 3,000 hectares of seagrass. We lost about 1,000 hectares. And so that's why that was rated as poor. And then very poor is the Central IRL, and that was rated very poor because there's pretty much no coverage of seagrass. And that was consistent from 2023 to 2024. Okay. Sediment health is something that I do as a benthic ecologist, and I think it's very important for it, and it's an indicator of health for the lagoon. And if you want me to go all science nerd afterwards, bring me some questions. But sediment is crucial, right? So if we are planting seagrass all over the lagoon, but we're planting it in muck, it's not going to take, it's not going to do well. And so if we know where there's healthy sediment, we can pinpoint where areas of restoration should be. And so what we look at with sediment health is we actually take a scoop of that sediment from the bottom of the lagoon, and we put it in an oven, and then we put it in a furnace, and that tells us the water content of the sediment, so how much water to sand ratio there is, and then how much organic matter is in it, so like how much carbon and that kind of thing. So in the furnace, that actually burns off. And so we take the weight before and after the furnace to tell us how much organic was actually in that sediment. And that's important because the higher the organic matter there is, so over 5% is unhealthy. And so when we have things like muck that are 27% organic matter, we can pick out those areas and say, not good for seagrass planting, not good for restoration, needs a little bit more work. And so that's what my dissertation's on, if you want to read it. However, because sediment is a little bit understudied, in my opinion, we only have sediment data from 3 of the 5 basins in the lagoon, which is why it wasn't included as a category grade for the overall health for all of them. Because if we included it for 3 and not the 2 others, it would have skewed the data. So in this, we have our good ranges from 0 to 5% organic matter, and then we have all the way up to more than 15.1%, which is very poor. And I'll show you some basic examples in a little bit. And then this was also new this year. This is wastewater spills. So this data came directly from FDEP. Thank you, FDEP, for providing. If you guys are interested in what these points are, please go to our data files, which you can get to through the report online. It will actually show you each of these individual points, who was responsible for it, what it was, if it was untreated or not, and whether it actually leached to the lagoon or not. And then the total volume as well. And so that went into one of our categories as well this year. And then finally, the more complicated one was water quality, right? So we took water quality and identified 6 of our main indicators for that. So again, chlorophyll A concentration. So we talked about that earlier with the harmful algal blooms. pH, which is how acidic or basic the water is. Turbidity, which is how opaque the water is, if you can see your foot when you put it down in the water or not. Total nitrogen and total phosphorus, which I'll talk about in a little bit in some more detail. And then dissolved oxygen. So how much oxygen is available to those living things in the water. And I have over here an example of where we got the values for those grades or assessments. And those are all from the US EPA. So Environmental Protection Agency is where we got those numbers, and then we broke them down into our categories, and that's how we got our assessments. Oops, that's the wrong way. Okay, I wanted to show you Watershed Information Network because it's this is where we got a majority of our data, but it's not super straightforward. And so if you ever have questions about Watershed Information Network, I spent the last 3 months of my life spending most days on it. I can show you. But basically what we're seeing here on the bottom is all those little blue points are all the monitoring stations where that data is being collected that we're using. So if I go, excuse me for a second, you guys. Share this one. So when you get to Watershed Information Network, yeah, you can see it. This is what it looks like. And so it's not super straightforward about where you can get your data. And so over here on the side, it says, I would like to, and so we go down to learn about the data in my area. Click on that, and it'll pull up this whole form, complicated form about how you get your data. And it's not very straightforward. And so we're gonna go under, let's look at some dissolved oxygen. So we're gonna go under the analyte name. So it's DEP analyte name. We're gonna go dissolved oxygen. And we're gonna add it, we have to add it. And now this is where it gets a little bit confusing. Because if you wanted to say you lived in Titusville, and so you say, I wanna see the Banana River Lagoon. When you go to all of these, what is a HUC12? I don't know. What's a VMAP? Maybe you know. What's a WBID? Those are all numbers. It's not really super straightforward. And so what we're gonna do is we're gonna go to the BMAPs, and let's go with the Banana River since I picked that out. It's gonna pick all of those monitoring stations from the map in Banana River Lagoon. So if we go here, it'll take all of these ones. And then let's say we're gonna do our start date, so 2023 to 2024. And we're gonna run a report. Maybe, if it wants to. All right, and so now it tells you, well, how would you like this data? Personally, I like their on-screen reports because it's already in a nice table. If you do use the extraction tool, it does put it into a text file, which then you have to convert to an Excel file. If you want to know how to do that, my husband built a software program for me so I could do this quicker. I have it if you want it. But basically, we're going to do show report. And then this tells us all the data. So this is the organization that collected it. So all of these ones are St. John's Water Management District. We go over, we see that there was a surface water sample taken on 9/12 of 2023. Yep, there's the water management district. And then it tells us the DEP analyte name, which was our dissolved oxygen, and the result. So, and that's in milligrams per liter. And so this is the data that went into so this data went into the Banana River dissolved oxygen subgroup of the water quality. So you can see why this took some time. Okay, I just wanted to show you when, because I think it's important, and that's where a lot of our data came from. I also wanted to show you Aquarius. Where's Aquarius? So Aquarius is the St. John Rivers Water Management District's tool. So it's not the entire lagoon, it is just the St. John's River Water Management District. And you can see these are their continuing monitoring stations. So they have 6 throughout the entire lagoon. And then we can pull data from there as well. So this is pulling dissolved oxygen up here. We can set those to whatever we want them to be and find data from those continuous monitoring stations as well. And I'll talk about Aquarius a little bit more in an example. PowerPoint. Oh, okay. So let's talk about the individual indicators for water quality. These were our ranges. So good water or good chlorophyll A concentrations in our data collection were considered under 5 milligrams per liter. That was set by EPA standards. We also have talked to water quality experts in the field, and they gave me some really excellent, thank you so much, significant guidance on setting these values and how to manipulate the data. And so these are the values for chlorophyll A. Here's pH. So our good pH, our optimal is between 6.5 and 8.0. And then you can see the breakdown for okay, poor, and very poor. Same for turbidity. So this is how opaque or clear the water is, how well you can see through it. And so that is an NTU. And so here our good values are less than 1.5. Okay, here's total nitrogen. So I've gotten some questions about why we did total nitrogen versus nitrate and inorganic nitrogen as well. And so what we did, why we chose total nitrogen instead of those individuals is total nitrogen takes care of all of those. So ammonia, nitrate, all those inorganic and organic nitrogen sources in the lagoon. Versus us taking them individually and weighting all of those. If I had an ammonia category, a nitrate category, and then like an inorganic nitrogen category, when we went to grade, nitrogen would overwhelm all of those averages. And so we didn't want that to happen. Nitrogen is really important, but it's not that important. And so we didn't want it to weight too heavily. So here's the nitrogen cycle, if you're not familiar. So when we're talking about total nitrogen, we're talking about our decomposers. So our animals are releasing into the water, and then we have ammonia compounds, which then are decomposed by a bunch of bacteria, into nitrates and nitrites. So our total nitrogen accounts for all of these forms of nitrogen, not just one. Same thing for phosphorus. So we have phosphate, inorganic and organic phosphorus, all included in our total phosphorus values. And why phosphorus is important is because of the phosphorus cycle. So natural and human inputs, that's things like fertilizer and runoff coming from land. And then we have our inorganic phosphorus going into the water column to be processed by a bunch of bacteria and cool things. And so we have inorganic and organic phosphorus. So total phosphorus accounts for all of those instead of just an individual one. Oops, wrong direction. And then dissolved oxygen. This is one we hear about a lot, because when our dissolved oxygen drops is when we get things like fish kills even manatee deaths and that kind of things. So dissolved oxygen is how much oxygen is available to living things in the water column. And so we want high dissolved oxygen. We want things to be able to breathe. Now in the past with the lagoon, we've seen when we have heavy rainfall events, what's called stratification. And so stratification is when we get a big layer of fresh water sitting on top of salt water. And that actually traps the oxygen and lowers the oxygen level in that bottom layer. And so the things that are in that bottom layer of water really struggle to respire and breathe. And so low dissolved oxygen ends up with things like fish kills because the fish aren't getting enough oxygen. Okay, so here's an example of our data. So we had a lot of questions about the Titusville area, which is fair. So I wanted to show you, this is from Aquarius. So that was that St. John's River Water Management District data. I always forget the river. Sorry, St. John's. And so this is what their data for the whole year looked like. Oops, I keep going the wrong direction. And so we have an average of about like 6.5-ish, maybe 7. And when we compare that to our data, as you can see up at the top, our average value was 6.83. And so remember back to our means and medians, with each individual of these, we did median values instead of means. So we did, this should be median value. And that was on the advice of water quality experts in the area. And the reason is because if we do an average, and that takes all of our data into account, if we have an extreme event like this one, where the dissolved oxygen was incredibly high, or this one, where it was really, really low, it'll take those extreme values and incorporate them into the average. And so we do a median to find the most common number without taking what we call our outliers, our extreme highs and our extreme lows. And then, again, that was on with contribution from water quality experts. And so, okay, now we're into our maps. You've all seen this. So this was our overall health map. It's pretty yellow. And that means okay. And so our 4 out of our 5 basins got an okay grade or assessment. The central IRL was the one that got our poor assessment. And we'll talk about why. So let's start with the Banana River. In characters with bananas, most of Banana River was yellow or okay. So the harmful algal blooms in the Banana River this year were rated as okay. That was based off of the average chlorophyll A values, and the median chlorophyll A value, which was used for this assessment, was 6.4 micrograms per liter. And that was a result of 3 harmful algal blooms. And so we had a pretty good year. It's a pretty standout year. We didn't have heavy rains that resulted in stratification and fish kills. We didn't have a ton of Okeechobee discharges. So we didn't see as many harmful algal blooms and fish kills as we have in other years. And that's not to say that next year we will see the exact same thing. Next year is up to the hand. We'll hope that we don't get some extreme rain events, but it's Florida. It's going to happen. So remember that this is a snapshot from August 2023 to August 2024. And in that time period, we only had 3 harmful algal blooms in the Banana River. That's pretty good. Okay, so let's talk about the sediment health, which is my area of expertise. So remember we had 3 out of the 5 basins had sediment health data. This is all my dissertation data. So here's Cars Park, which is one of my dissertation sites. So I sample this quarterly. And so we have data from these sites showing that the sediment in these areas was healthy. Now we have to take this with a grain of salt because this was an area that had living shoreline restoration. And so there was a restoration effort made here. And before that restoration effort was made, the sediment was not good or healthy. And so that's why sediment wasn't included in that overall grade, because sediment health, when you look at this, we only have 7 points here. I can't tell you that the whole basin sediment is the same as these 7 points. And so if you have more sediment data, please share it with me. I would love to have more so that we can include this. Same with Sykes Creek. So we're all familiar with Sykes Creek. That's where Sorrel's environmental dredging program is going on. Thank you, Sorrel. And so these are points from FIT's data collection at that area. And so, and again, we're taking this with a grain of salt because this project is looking at these red dots. These are the muck pits that exist there. And so we have zoned in on those areas because we want to know more about them. So again, this isn't going to go into the overall grade because it's only a very small area of the Banana River Lagoon that we actually have data for. But it's important data. Okay, wastewater spills. Banana River wastewater spills were actually not horrible this year. Sorry, we're gonna catch up. There were 25 wastewater spills from 800 to 900,000 gallons, which seems like a lot. Only 6 of those actually reached the lagoon. So 5 of them were untreated. The big one, that 900,000 gallons, was actually treated. And so this data is important. So if you go into our methods and you look at our data, you can actually see what each of these points is. And so it's important to note the difference between untreated sewage and treated sewage reaching the lagoon and what that means for the overall health. Okay, seagrass coverage. So remember, this is the one that's a little bit different. So we're doing better, which means we've significantly increased in coverage. Okay, which means we've had about the same coverage to slight increase, poor, slight decrease, or very poor, significant decrease in seagrass. And so even though the Banana River Lagoon still has only about 100 hectares of seagrass, it didn't decline or increase compared to last year, which is why it was rated as an okay. And then finally, for the Banana River at least, is the water quality. And so overall water quality, so these are median values, the median values of pH, median values of turbidity, and so on. And then we average these, so the mean, to get the overall water quality grade. So for pH, we were good. For turbidity, we were okay. Total nitrogen was very poor. So we had a lot of nitrogen in those sources. Phosphorus was good, dissolved oxygen was good, and then chlorophyll A was okay. And that goes along with our harmful algal blooms, right? So we had an okay grade for our harmful algal blooms as well, because there are only 3. And so the average water quality assessment for the Banana River Lagoon was okay this year. Mosquito Lagoon. So Mosquito Lagoon is my happy place. They did really good this year. We like them a lot. So Mosquito Lagoon had 0 harmful algal blooms this year, with a median value of chlorophyll A at 3.4. And so, sorry, yeah, that was the median. The average was over 5, less than 5, excuse me. And so that received a good grade for harmful algal blooms because there weren't any. Now, sediment health. Here's my issue. I have no data for this one. And so that's why, again, like we said earlier, this wasn't included, sediment health wasn't included in the overall grade because it wasn't fair to the 2 basins I didn't have data for to have a weighted grade. And so this is blank, there's no sediment. If you have sediment, let me know. Wastewater spills, really good year for the Mosquito River Lagoon. We had 3 spills, which you can see, and none of them reached the lagoon. And then our seagrass coverage, we had a significant increase from 2023 to 2024. So in 2023, the Mosquito Lagoon had about 3,800 hectares of seagrass. This year, we've seen over 6,000 hectares of seagrass. So that's a significant increase in coverage, and we are going to rate that as a good. Okay, water quality. So here's the breakdown of water quality. Very similar to Mosquito Lagoon. So our pH, dissolved oxygen, and chlorophyll A are good. Our turbidity, so how clear the water is okay. And then total nitrogen is poor. It's going to be pretty similar for every basin. We have a lot of nitrogen in the Indian River Lagoon. And then the one difference is that their total phosphorus was okay versus good. Okay, let's get into the North Indian River. So the North Indian River Lagoon had 1 harmful algal bloom this year, but the average, or the median chlorophyll A content was about 11. And so that put us into our okay range for that basin. Similar to the Mosquito Lagoon, I don't have sediment data for the North Indian River Lagoon. I think University of Central Florida has it. Call out UCF if you want to bring it to me. I would love it. North Indian River Lagoon had 31 wastewater spills, so we're increasing in numbers here. However, only 4 of them reached the lagoon, but of the 4 that reached the lagoon, it was untreated sewage. And then for seagrass coverage, we had a significant increase in seagrass coverage in the North Indian River Lagoon this year as well. So in 2023, we had less than 100 hectares of seagrass in the North Indian River Lagoon. In 2024, we have just about 300 hectares of seagrass. So it's a pretty significant increase. And then our water quality for the North Indian River Lagoon was rated as okay. And again, here are those breakdown values. So again, our nitrogen is very poor. And this is a little bit different. Our chlorophyll A for this one was also rated as okay, as we talked about earlier. And so overall, when we average those together, we got a assessment of okay for water quality. All right, Central. Yay, Central, here we are. So Central Indian River Lagoon is doing okay. It's doing all right. We had 2 harmful algal blooms from August to August, with an average of 5 or a median of 5.5 micrograms per liter. And so that puts us in that okay range for harmful algal blooms. Now we do have sediment data for the Central IRL. Thank you, Dr. Holly Sweat from Smithsonian. We love her. So again, for this entire long basin, we only have these few points of sediment. They give us a really great insight into what's going on at those locations, but it's not enough to actually factor into our assessment. And so from the Smithsonian data, we can see that these specific points, which they sample 4 times a year, are rated as good sediment quality. Now the wastewater spills for Central Indian River Lagoon, we had 52 spills. 9 of them reached the lagoon, 7 of which were untreated sewage. 1 was partially treated. And then, but this is the one where we had 1,333,000 gallons. Luckily for us, that one was treated. So it was not untreated. So the big spill here was treated sewage. And again, you can see all of those details on our data sheets. Now, seagrass coverage. We love the Central IRL, but we're not doing okay with seagrass. So unfortunately, there is virtually no coverage of seagrass in the IRL and Central IRL, which is why it was rated as very poor. But we're making progress. And so as we talk about the project highlights later, we can talk about some projects that are in the Central IRL that are doing some really great things. But water quality. So Central IRL water quality, here's our breakdown. So our turbidity was poor, which matches what I see every time we go out there. It's really hard to see through the water. Nitrogen, again, very poor. Our total phosphorus was just different from all of our other basins. And so in the Central IRL, we actually had poor levels of phosphorus. Everybody else was like okay to good, which is why we took it down a step into our poor quality assessment for Central IRL water quality. Now the final one, bear with me. South Indian River Lagoon, we had 0 harmful algal blooms with a median value of 4.1. And so that puts us in the good category for harmful algal blooms. Sediment health, again, this is all from the Smithsonian. So thank you, Dr. Holly Sweat. Again, you can see that these specific point locations, that sediment was good, which is a good indicator, but we need more data. Wastewater spills. They had 79 spills, so they actually beat the Central IRL in a not so positive way. But only 7 reached the lagoon. Unfortunately, all of them were untreated sewage. And then for the seagrass coverage, we actually had a slight decline in seagrass coverage in the South IRL this year. So we went from 4,000 hectares in 2023 to just about 3,000 hectares in 2024. And then finally, our water quality for the South Indian River Lagoon was rated as okay. Here's our breakdown. And so the turbidity and nitrogen were poor, but our other indicators were pretty okay to good. And so that earned them an assessment score of okay. And that's it. So let's talk about some questions, because I know you have them. I'll bring Laura back up here because she's gonna answer some too.
Yeah. So again, we have the cards in the back. Again, this helps keep things balanced between online questions and the classroom-based questions. And so we can collect these.
Yeah.
I'm gonna is gonna moderate.
Yeah, so if you have the question cards filled out, raise your hand. I'll put that.
So like all of you.
Yeah. And then she'll read them out loud, so
Yeah.
everybody online can hear them
And
as
then
well.
she will be going through the Zoom chat, the Q&A as well. So don't feel like you're left out, Zoomers.
And cards here.
Isn't that what we call Jen?
Question card. Okay. So.
I don't know if you want to have this screen on or not, but it's just us.
Okay.
Going into infinity.
Well, it's not.
Yeah.
Okay. What are the nitrogen sources in the lagoon?
Oh, that's a really great question. There are abundant.
So the question is,
Louder.
what are the nitrogen sources in the lagoon?
So there are tons of sources of nitrogen to the lagoon, most of which unfortunately come from humans. But there's a natural nitrogen cycle in any water body. Nitrogen is a naturally occurring compound. It is when it gets into high concentrations that it's a problem. And so unfortunately, what we've achieved in the lagoon is called eutrophication. And so that means that we've put too many nutrients and things into the water, and so that it's way too productive in a bad way for our nitrogen and our phosphorus.
Can you speak to the human input?
Oh,
of nitrogen?
absolutely. So things like fertilizers, that's also a source of phosphorus as well. Animal feces, unfortunately. So pick up your dog poo if you're pick up your dog poo anyways, but especially if you're along the IRL, we really appreciate that. But there's tons of sources. Sorrel is a really good, sorry, I do the acronyms. Save Our Indian River Lagoon, or Sorrel, is a really good source of for information about what you as a homeowner can do differently to impact the lagoon in a positive way. Do you have anything else to add?
And I think if I remember correctly, South Indian River Lagoon was the only basin, I think, that wasn't very poor on nitrogen.
I
So
believe you're
nitrogen is troublesome across pretty much every basin, with the
Yeah.
best grade being a poor.
But you do have to take that with a grain of salt because there are natural sources of nitrogen. So that is why I talked with water quality experts to set those values. And that's why we went back to the EPA to set those values as well. Because there is a normal amount of nitrogen in any system.
Fish poop. bird
Yep.
poop.
Yep. Everybody poops.
Yeah.
Okay. Does the wastewater parameter take into account untreated sewage from boats moored in the river or campers on Spoil Island?
It does not.
No.
We, like Mara said, all of the wastewater data came from the Department of Environmental Protection, Florida DEP. And to my knowledge, that is like the water-based kind of outflow from boats
Mhm.
is not monitored or
No.
measured outside of individuals and continuous water monitoring stations.
Correct.
Those are really the only way those data get in. FDEP has a mandatory report process for any sort of spill that happens on land, whether it's a construction crew breaking a sewage pipe or an overspill or release from a treatment plant. Unfortunately, the others are not monitored. And this has actually been a piece of legislature that has been brought up and kind of pushed forward in terms of how we monitor or regulate when liveaboard boats can release waste and things
Yeah.
like that. It hasn't really gone anywhere.
Scoot in front of the camera. Thank you.
I kind of like being
Yeah, I'm sorry.
behind the tape.
Okay. So we know there's been a lot of money spent on dredging.
Mhm.
Do we know how this is impacting the sediment quality, and how can we include all the regions on tracking that kind of thing?
I can speak directly to that because I'm on the Sorrel Environmental Dredging Project as a researcher. So in Sykes Creek, they have removed hundreds of thousands of pounds of muck from these muck pits. And the goal of that is to eventually they will fill up again. But there's so much in there right now that it's actually leaching nutrients back into the water column and having a really bad effect. So the back to our nitrogen and our phosphorus that we talked about. So it's coming from being settled in that muck back into the water column. So it's making our water quality worse, which is why they're actually removing that. And so just to clarify, this is environmental dredging, not navigational dredging. So this is not something to clear the intercoastal waterway. This is something to improve water quality.
when we talk about things like legacy.
Yes.
It's that muck, right?
Correct.
Yeah.
Exactly. And so what the specific project I'm on is we took pre-data, so before dredging data, to see what the sediment health in those areas were. As you can imagine, it was not very healthy. And so I also look at what lives in that sediment, which is called benthic infauna. Sounds fancy, but it's just the little critters that live in there. And so what I look at is how many of those critters are in there, what they are, how many there are, and what the diversity is. So whether there's just one kind of thing there or a bunch of different organisms. And so when we looked at that pre-data, there was either nothing living there, so 0 things where there should be upwards of 45,000, or there were approximately a dozen of these they're called polychaete worms. They're these little worms that go through the sediment, and they're incredibly pollution tolerant. They actually create their own oxygen around them. And so they can, they do like a little shimmy. It's cute. I think it is. And so they can live in those low oxygen environments, which is why we find them, even in low abundance, in those areas. So now last year, they took all of that muck out. And so they put that into their DMNAs, the dredge material management area, and secured that material. And so it's not going to come back into the lagoon. And now we're seeing natural sandy sediments come back in those areas. So we go every season because what I study is seasonal. And so we go and look at it every 3 months. We're actually going out next week to do our last one. And it's improving. We're seeing things come back. We're seeing seagrass come back. We're seeing seagrass seeds in the sediment, which is really optimistic. We like to see seagrass seeds. And we're seeing a huge diversity of organisms. And so it's a really positive indicator for the health of that area, because though they're the base of our food chain, they're going to support our seagrass, which feeds our manatees, which feeds the fish and us and all of the higher things. And so for me as a benthic ecologist, it's really promising. And it's really, I actually did one of these about that project. So if you want to go back on our YouTube, feel free. You can also reach out to me. But that is the project that I'm on in Sykes Creek. Now there's other environmental dredging projects around. I just don't have that data to speak about.
And I think the easy answer is that there's a lot we don't know.
Exactly.
Studying the sediment and what's in it and using that as a health indicator is in its infancy.
It is.
And there's 3 research labs kind of across the state that are doing this in the lagoon. So shows great area for the science part of this to grow.
And with my FIT hat on, we do want to increase those kinds of projects. We want more data so we can build what we call, it's part of the, it's a SORL project. It's the IRL species biodiversity inventory. So that's also run by Dr. Holly Sweat, who I mentioned earlier. And so we're building an inventory of all these animals that we know are in the lagoon. The Indian River Lagoon is the most biodiverse estuary in North America, even now when it's impacted. And so there's tons of animals we don't know about. And so that's the interesting thing about sediment to me.
Awesome. What constitutes a significant difference in seagrass coverage?
Oh, that's a great question. So a level of significance is greater than 5%. How do I explain that? P-value of 0.5.
Yeah. It's a mathematical statistical equation that's used to determine the variance from between 2 different numbers.
Yeah, so I run it through an equation. It tells me if the p-value, which I know, I'm sorry, is significant, and if it is, then it reached into that the better category for that. Now, I have are you looking for the seagrass values?
No, that's what Twitter's for.
Yeah. Go all the way back to the seagrass one. Yeah, so for the slight increases where it didn't reach that significant value or the p-value of 0.05, that's where it went into the better category, or the okay category, excuse me, not the good, because we did still see an increase, it just wasn't significant. And then the same with the decreases as well. The one exception being Central IRL, where there was just no coverage, and that was also rated as poor because there was 0. But did that answer the question?
I think so.
Okay.
Does the seagrass data distinguish between seagrass that comes from seeds naturally versus seagrass that might have been restored in an area?
No. And that's something I'm interested in. So if you have thoughts about how we can differentiate that, please let me know. But no, the coverage data that we got from, it was from 2 sources, from FWC and from Sorrel, was including all seagrasses, including restored seagrasses.
For water quality, how are you considering the sampling depth, so surface versus maybe bottom?
Yeah.
That can affect the comparison.
That's an absolutely great question. So that's something I considered and I talked to our experts about as well. We did decide to do surface data because it was the most abundant. Most organizations that contribute to Watershed Information Network only take that surface. They don't do the depth. And so just the amount of data at bottom at depth was way smaller than our surface layer data.
Is there a roadmap, or could you maybe describe the differences between the old report card and the new report? Is there a way to compare what's been added, what's different?
I can try. So based on my knowledge of the old report card was a lot of site data, and site specific data. This is taking snapshots of basin-wide averages. So what's going on in the basin, again, with the intent of getting clear messaging across, versus kind of getting into the detail of one inlet versus another inlet. Data like those are available where we have, or not we, but where, you know, either Orca or St. Johns River Water Management District have their continuous monitoring devices. So that's one difference in terms of how we're reporting point data versus basin data. You know, the other was we did wastewater spills,
Yep.
reporting the wastewater spills. We added sediment data.
Just remember
I'll
that
know
this
the
was
water
our first
quality.
year doing it in-house. And so comparing it to what we've done in the past is tough because it was a team of researchers working on it and doing, I had trouble with the methods document. So it wasn't in my skill set to reproduce what a whole team of researchers could do. So it isn't directly comparable. The hope is that moving forward, since we've set these methods, that it will now be comparable.
Right. And since the methods are set, the heavy lifting on that side is done. So we can go back and look at previous year's data and not just move forward, but start adding backwards. Again, because we didn't set the methods for those previous reports, we couldn't replicate them. And this will be able to replicate and then backcast and move forward.
Yeah.
But that's a good question. And
very
that's
good
really
question.
hard, you know, not having those direct comparisons.
Yeah, and that's something that Laura and I talked about a lot when we were setting the methods.
Yeah.
For sewage spills, are they only from treatment plants or are they from other sources?
Every source that DEP monitors. So it's construction projects, it's contractors, yes, wastewater treatment centers, absolutely. But it's a variety of diverse sources, and you can see that all on our data sheet.
Yeah, and if you're interested, you can actually sign up for the emails.
You can.
I get them for all the basins now, so I'll get anywhere from 0 to 4 emails a day for when somebody's trying to repair an internet line and they hit a sewage line and 5 gallons spill out and what they do with that. So
they also have those emails for harmful algal blooms. If you're curious about them.
Yeah.
Was any information from tributaries included this year?
Not particularly. So when you go and look at the WIN Watershed Information Network map, you can see the specific locations that we took. So all the water, the data points that we took were actually within the basins this year. The tributaries are absolutely important. It wasn't in my capability to add that this year. We want to moving forward.
So that's definitely a place where we can grow.
Yes.
Moving forward to add that aspect of lagoon health.
And so if you have thoughts or considerations, let us know. I'd love to hear it.
Going back to wastewater again.
Yeah.
Does the data you use have a breakdown from what percentage is due to residential, what percentage is due to commercial or county, sort of stuff like that?
You could find that out in the table because they have it as a category, but it's not specifically grouped that way,
Within.
if
our-
that makes
yeah.
sense.
It's not grouped that way within
Our
our
sheet.
presentation.
Yeah, but you could go into that Excel sheet and click the category that for,
And sort of.
and sort it, and then you could see the groups.
Okay. For the overall water quality score, was it the average of all the parameters averaged over the year?
So this is where we got confusing, right? So between the mean and the means. So each of the individual, so dissolved oxygen, pH, turbidity, all of those had median values. And then they were sorted into good, okay, poor, or very poor. And then that was taken into an average value, so the mean for the overall water quality assessment.
Meaning like if it was good, it got a 4.
Yep.
If it was poor, it got or is 3
3
to
to
0. And then we took an average grade. So within the average of those 6, they were weighted equally.
Correct.
Which is why we use things like total nitrogen versus having 3 different nitrogen and pretty much triple weighting.
Yeah.
That aspect of it.
Now, you may have noticed that we did actually weight chlorophyll A in here because we did have it for HAB, so harmful algal blooms, and water quality. That was on the recommendation from our water quality experts.
Also related to water quality, is there a reason that salinity wasn't
Yes.
included, considering how important it is for habitats?
Thank you. That's a fantastic question. I was waiting for that one. So I went back and forth with our researcher, our experts about whether or not to include salinity because we are in an estuary. And so if you go out to our shoreline today, it is probably about 22 parts per thousand salinity. Yesterday, it was probably like 14 because we had rain-ish recently. Both of those are okay salinity values for an estuary. So there are huge twists and turns in our salinity that are still considered healthy. And so between myself and my researchers and the experts I worked with, we could not figure out a way to effectively grade salinity. It is absolutely important. If the salinity is way too high or way too low, it is harmful for the lagoon. But we could not get it into a form that was actually being able to be assessed because of how variable it is.
Yeah. And this isn't just like an MRC problem.
No,
This
it's
is
not.
pretty much anybody who does water quality testing and reporting has the same problem because it's so variable hour to hour.
Yes.
And meter to meter.
Yep.
Depending on the point source of that water. So it's really something that we collectively as a scientific community haven't figured out how to reliably report it so that it actually means something regarding lagoon health. So it's very important, as Maura said, but it's very complex.
It is.
And we haven't figured that out yet.
If you had a breakthrough, let me know.
Yeah. You get a nature paper on it.
Yeah.
Also related to water quality, was Lagoon Watch data used in the report, and was there any comparison done between Lagoon Watch data and the data?
So within WIN, which is the Watershed Information Network, where most of our water quality data were pulled, our turbulence, essentially turbidity data go into that. So data were used for that. We also linked to the bacteria data, which we do some, and then why am I blanking? The Space Coast, who does the bacteria?
Chris Baker.
Chris Baker.
Surfrider.
Surfrider,
Thank you.
Surfrider does the bulk of it. We contribute to that as well.
Yeah.
One of the things that I would love to do with our 30 years of Lagoon Watch data is actually go back and plot those to look at how those have changed over time, since it's, you know, been continuous within the lagoon, if not at sites, for a 30-year period. One of the things that we have talked about as an organization, that that predates me, but has resurfaced later, is to do lagoon monitoring using our methods next to something like a continuous monitoring station to look at the comparisons in the data quality and the data accuracy comparing between those two. So that's very much on our radar for how Lagoon Watch data compare to the new technology that have come out, as we've had a lot of discussions over the last couple of months about how to evolve our Lagoon Watch program.
But to speak more to, because it was like comparing it to DEP data. So Watershed Information Network data comes from tons of organizations, including DEP, including St. John's River Water Management District, including Lagoon Watch, Surfrider, Orca, etc. There's tons and tons of organizations that add their data to this network and database. Now they all have to be using the same methods, and they have to reach EPA standards. And so that's where the comparison question kind of comes in, is yes, it's comparable because they're using the same methods and it's reaching the same standard.
Okay, this question, their understanding is that water temperature is on the rise. Does the temperature have an impact on the water quality?
It sure does. So usually what we see with increasing water temperatures is that's where we see dissolved oxygen drop. And so we accounted for that water temperature using our dissolved oxygen parameter in our water quality data.
And it'll also affect things like pH.
Yep.
Colder water can more readily dissolve things like carbon dioxide, which then converts into carbonic acid, so can change acidity as well.
Yeah.
How do this year's results compare with applicable water standards?
So that is, if for the water quality metrics that we use, that's the direct comparison, because our breakdown of the good, okay, poor, very poor is directly correlated to what the US EPA standards are. So those are where we talk about, like, these are absolutes. These are numbers that are averaged over the basin and compared to a nationwide standard.
Can you emphasize the importance of low impact development to reduce or eliminate the return of legacy muck?
Absolutely. So to go back to our Sykes Creek example, so as I boat around there, it's all manicured lawns straight up to the lagoon, right? And so we're not having any filtration of nutrients re-entering the lagoon. Sorry, can you reiterate the question?
Can you emphasize how important
Oh, yes.
low impact development?
So when we talk about low impact development, we're talking about things like working with nature when you build a home. So as a restoration person, the first thing that pops into my head is buffer zones. So usually that's about 4 feet of vegetation that's native and able to grow without being mowed between your house and the lagoon. It'll absorb nutrients that come from your yard and your rainwater before it hits the lagoon. And so that's going to absorb those nutrients that eventually turn into our muck, which end up in our muck pits, which end up needing to be dredged.
Yeah, there are really cool images out there. So most recently I was in the Midwest, where native grasses is a big thing, really for these same reasons, is that if you look at the root system of manicured lawns, it's a couple of inches. If you look at the root system of established unmowed native plants, it's going to be feet deep. So that is more root to stabilize a shoreline versus erosion, but to pull those nitrogen and phosphate molecules out and store them in their bodies before that water gets to the lagoon.
Yeah.
So that's why, whether you're talking, we have a great buffer zone around our retention pond in front of the lagoon house. You'll see all that native vegetation that doesn't get mowed. And then also living shoreline, while we talk about mangroves, while we talk about the oyster beds and the seagrasses and stuff along the shoreline, is to help with absorbing those nutrients before they can get out into the lagoon to cause muck. So a lot of low impact development is how to stop water and everything that it's carrying in it between a property and the river or the lagoon. And so plants and allowing that water to infiltrate versus just flow across a manicured line or concrete is how we address that through low impact development. what we're starting to call here low impact living, because it's not just big corporations and their building, it's us as homeowners as well.
Is there a reason that you used absolute values for some of the parameters versus increase or decrease for?
Oh, yes.
Yeah, I
Yeah.
mean, so the increase and decrease was the seagrass, and that was because we couldn't access the data that we needed for the absolute numbers.
Yeah,
So
I
we-
wanted
we-
it to be absolutes. I didn't get the data on
We
time.
analyzed the data we had.
Yep,
Good
and so
access.
I have that now, and so hopefully moving forward, we will have absolutes for that. Yeah, no, that wasn't ideal. We wanted it to all be absolutes, but that's life.
Yeah, we definitely know that that's an area where we can improve upon next year
For
and how
sure.
we report that. And that's why it was, I mean, in full transparency, it was a very last minute decision.
It was.
But when you go to the report, you'll notice that green is better and not good. So we actually tweaked the language at the last minute to try to reflect that that's a comparison versus absolutes like the other.
Awesome. If you had to pick just one
Oh my.
source of high nitrogen levels,
Oh,
and then is there a relationship between nitrogen, phosphorus, and oxygen levels?
yes.
The two-parter. You want me to-
Okay,
So pick one, like kind of like the main source of
Yeah.
nitrogen.
The biggest
predominant-
one you can think of at least.
I mean, fertilizer immediately is mine.
Do you think that's bigger than poop?
Probably not. It's just what I study, so I'm biased. Yeah, probably wastewater. Oh, that's a tough one. My brain's gone a mile a minute.
Yeah.
Yeah,
So I'm
Go ahead,
starting,
Terry.
Sorrel started out, legacy load was considered to be
Oh.
the biggest load. Over time, that thinking maybe has been adjusted a little, but my first, so it's a two-part question.
Yeah.
My first answer is no, I can't pick one source.
yeah,
There's
Yeah.
several.
there's
and
so
they're
many
all- yeah.
sources.
I mean, and they're all a problem. They all need to be addressed.
Correct.
And the second part.
Is there a relationship between nitrogen, phosphorus, and dissolved oxygen?
Yeah, so the nitrogen and phosphorus cycles are interlinked. If you really want me to go into, I need like a whiteboard. But yes, everything is interlinked, including the oxygen. So when you have really high levels of nitrogen and phosphorus, we have lower levels of oxygen and vice versa. And then there is a healthy, happy medium that we like to achieve. Unfortunately, we're not achieving that in the lagoon at the moment.
Yeah, so nitrogen and phosphorus can come from the same sources.
Correct.
Like poop and fertilizer. And then nitrogen and phosphate can also bond with oxygen in the water, removing that free oxygen, not allowing it for the fish to
Correct.
breathe anymore. So it is the easy answer to everything is that it's very complex. And it really is, like, even coming down to the science of studying the molecules
Yeah.
that can be causing problems. And they're all interlinked with each other. And that, I mean, from a scientific perspective, makes it fun because who wants
Yeah.
to solve an easy problem? But from actually solving the problem makes it very, very difficult
Yeah.
because there's not one answer.
Right.
There's not one solution.
And so like for an example of that in our muck pits where we take that nitrogen and phosphorus levels, obviously they're going to be high because that's where our legacy loads are. And that dissolved oxygen is, if not zero, almost zero all the time. And that's because that nitrogen and phosphorus that's getting released into the water column it's called fixing, is taking that oxygen and using it to form a different form of itself, which settles down into the sediment. But that means that oxygen is no longer in the water column for things to benefit from. So it's complex.
Yeah. I will say, so we are after 1 o'clock.
Oh, I'm so
If
sorry.
people need to leave, we are happy to answer questions. We are still recording and this will go up on YouTube. So you're welcome to stay and keep the dialogue going, but we understand if you want to drop a question and run,
Yeah.
and we'll answer it on film later.
My card is in the back. You can email me questions. I'm happy to answer.
We got a couple more.
Yeah, I know. Yeah. It just feel free to
Okay.
leave if you need to.
Yeah.
Of course. Is PFAS, maybe you can define that for
PFAS.
us, monitoring a part of the water quality, and why or why not?
Repeat it again. If it's included in the water quality analysis.
Is PFAS is monitoring a part of the water quality?
So do people who monitor water quality, do they monitor PFAS?
Some do, some don't. So that wasn't included in our water quality analysis. Cara's got an answer. But not very many groups do it, and so it's not an abundant enough source of data for us to actually give it a basin score for that kind of stuff. PFAS is very important. It's been in the news. We all know about it. But it was not included in this year's assessment.
Can you define PFAS too?
Oh, no.
PFAS is, I can't, it's
It's
phenol something or other.
polyfluoroalkyl substances.
Yeah, they're the forever chemicals.
Yes.
That get used as flame retardants is the big thing everybody can relate to. Like when kids' PJs used to be, made flame
Yeah.
retardant, fire, okay, that's good.
Yeah, that's good.
We don't want kids to ignite. Firefighting
Yeah,
foam
I heard
is a big
Teflon.
thing. A lot
Teflon's a
of
big one.
military bases and firefighting groups have used PFASs in their chemicals for years and years and years. So these are chemicals that do not degrade.
Yeah.
Do not break down. There is some science out there now that they are trying to find some bacteria that might be able to munch their way down and reduce the badness of the
Yeah.
chemicals. But that's what PFASs are.
Yeah, so they're linked to cancers,
Big
they're
picture.
endocrine disruptors. They're not good at all. But unfortunately, we didn't have enough data to include it.
They're used in non-stick cookware.
Yes, they
So
are
like
used in
Teflon,
nonstick
yeah.
cookware like Teflon.
Yeah.
Google it and you'll get a whole list.
But no, I think this is, and again, this isn't like an MRC only issue. This
Right.
is lagoon-wide, worldwide, that
Yeah,
we
worldwide.
aren't doing a great job of monitoring these and really understanding their life cycles and lack thereof.
I would like to thank Cara in the
Yeah.
back. That was Cara, our Lagoon Watch coordinator, and
Okay, last one.
Okay.
Ready?
I'm ready.
What are the most important additions or changes that you want to make for next year's report?
Oh, that's really good. So main one for me is getting absolute values for seagrass. That's mine. I would like to add some more parameters to water quality, but I want it to be something that then again, we can take back and do. So I didn't include it this year, but I can do 23 to 24 next year with those variables and go back as well. So we've gotten a lot of really good suggestions
Yeah.
about what to include. I don't
For me, I think it would be taking it back in
Yes.
history.
Yeah.
So looking at maybe a couple of years back and then major events that we can get those data for.
Yeah,
So, like 2011,
2019,
2019.
2020.
Yeah, and it's kind of periodically as we go back into the history of the data. One of the issues that was kind of brought up in one of those questions is how data collection and data collection standards have changed.
Mhm.
So there are comparability issues as you get more and more historical, but I think adding historical data is
Yeah.
important because we all talk about restoring the lagoon. And it's very vague what the goals are
Yeah.
and what we're restoring
Exactly.
it to, what's actually gonna be achievable versus what's going to make, long-lasting positive impact on biodiversity and human health.
And I realized that I didn't make a slide of it, and now I feel bad because it was like one of my favorite things about the report is this year we did include project highlights. And so that was from a bunch of contributing organizations from all around the lagoon, showing what they've done this year, why it was successful, what was important for, and where it was done. And so you can see a couple MRC projects on there.
And Sorrel and
Lots
IRL
of-
and
yeah.
EP also have similar
They
self-reporting
do.
databases that they send out. But,
And we link to those in the
Yeah.
project highlights if you need an easy link to it.
Yeah.
Okay, thank you, Laura and Laura.
Thank you, guys.
Thank you.
Good question.